In this video, let us solve problems based on finding the HCF of two numbers by using Euclid's division algorithm. So the numbers that we've got are big numbers, 4052 and 12,576. Quite huge numbers. Okay, now let us find the HCF between these two numbers. Now this is exactly why Euclid's division algorithm comes into play. It's like really handy to solve these kind of huge problems. So now start off with seeing which is the smaller number and which is the bigger number. Divide the bigger number by the smaller number. So here we've got 12,576 being divided by 4,052. So now you can see that 4 times 3 is 12. So 4,000 times 3 is going to be 12,000. So that's how. So 4,052 times 3 is now going to definitely cross this, because 52 times 3 is 150. It can't cross 576. So therefore, it's 4,052 times 3, which is 12,156. And the remainder here is 420. So it's got a remainder. So definitely 4,052 is not the HCF between these two numbers. So now you use the Euclid's division lemma and write this as this: 12,576 equals 4,052 times 3 plus 420. Just to, make sure you don't get confused, let me draw a box here. So this is the Euclid's division lemma. So now you know what? Make the divisor the dividend. So that makes it 4052 the dividend. And the remainder the divisor. So 420 the divisor. So how many times 420? It can't go 10 times, because if it goes 10 times, it'll be 4,200, which is greater than the dividend. So it definitely should be 9 times. So 420 times 9 is 3780. So now the remainder that we're getting is 272. Right? So now, again, write the same thing. So 4,052. The dividend equals the divisor times the quotient plus the remainder, 272. So this is separate, right? So as long as this remainder is there, you haven't found the HCF. That's what it means. So next thing, make the remainder the divisor, that is 272, and the divisor the dividend. 420 becomes the dividend. So 272 definitely should go not more than once. So 272 times 1 is 272, and the remainder is 148. So there is a remainder. We haven't found the HCF yet. So we've got 420 equals 272 times 1 plus 148. Here we are. The remainder becomes the divisor, 148, and the divisor becomes the dividend, 272. So 148 goes once in 272, so that gives us a remainder of 124. So now write the same thing. So 272 equals 148 times 1 plus 124. Now again, the remainder becomes the divisor and the divisor becomes the dividend. So 124 goes one time in 148 to get 124. The remainder is 24. So writing this, we have the dividend 148 equals the divisor 124 times 1 plus the remainder, which is 24. By this, we are satisfying the Euclid's division lemma. We're also using Euclid's division algorithm to solve the problem. So here the remainder becomes the divisor and the divisor becomes the dividend. 24 goes 5 times to get 120. The remainder is 4. So let's rewrite this as the dividend 124 equals divisor 24 times the quotient 5 plus the remainder. So well, here we've got this. And I think this should be the last, because you can see that 4 and 24, definitely 4 divides 24 perfectly. So we've got the divisor as the dividend and the remainder as the divisor. So 4 goes 6 times in 24. Then we've got a 0 remainder. So definitely 4 is the HCF that we've been looking for. So 24 equals 4 times 6 plus 0. So since we've got the 0, 4 is the HCF that we've been wanting. So 4 is the biggest number that could divide 4,052 and 12,576. Well, I didn't think, it would be such a small number. I thought it would be a little bigger, something like a 16 or a 24 or, 28, something. But well, 4 is the HCF. So therefore, 4 is the HCF of 4052 and 12,576. So this ends this problem as well as this video. So this is how you solve problems based on finding HCF of two numbers by using Euclid's division algorithm. So all you have to do is, first find the smaller number, divide the bigger number by the smaller number, and keep dividing until you get a remainder 0. That is, keep dividing what? The first divisor becomes the dividend, the next dividend, and the first remainder becomes the next divisor, and then it just goes on and on and on and on until you get the remainder 0. So I'll see you in the forthcoming videos with more concepts based on real numbers.